Service entrance cable, often referred to as SE cable, is used to bring power from the utility company's service drop to a building's main service panel. Whether or not it can be spliced depends on several factors, including local electrical codes and the specific application. Generally, splicing SE cable is discouraged and often prohibited, especially before the main service disconnect. The primary reason for this is safety. Splicing introduces potential points of failure, increasing the risk of electrical shock, fire, and arcing faults. These risks are amplified in the service entrance where high currents are present. However, there might be situations where splicing is unavoidable or necessary, particularly in repair scenarios. In such cases, strict adherence to the National Electrical Code, or NEC, and local regulations is crucial. If splicing SE cable is unavoidable, it must be done using approved methods and materials. These methods typically involve using listed splice kits specifically designed for the cable type and size. These kits provide a secure, insulated, and waterproof connection that minimizes the risk of failure. It is extremely important to follow the manufacturer's instructions precisely when installing these kits. Firstly, ensure that the power is disconnected and locked out before commencing any work on the SE cable. This is a fundamental safety precaution to prevent electrical shock. Secondly, thoroughly inspect the cable to identify the extent of the damage or the reason for the splice. Assess whether a splice is truly necessary, or if replacing the entire cable run is a more viable and safer option. Thirdly, use appropriate personal protective equipment, including insulated gloves and safety glasses. Fourthly, prepare the cable ends for splicing according to the splice kit manufacturer's instructions. This typically involves removing the outer jacket and insulation to expose the conductors. Fifthly, use a crimping tool specifically designed for the type and size of connectors included in the splice kit. Ensure that the crimps are properly made to provide a secure and reliable electrical connection. Sixthly, insulate the splice using the materials provided in the kit. This insulation must be rated for the voltage and environmental conditions of the installation. Seventhly, seal the splice to protect it from moisture and corrosion. This is particularly important in outdoor or damp locations. Eighthly, after completing the splice, inspect it carefully to ensure that all connections are secure and that the insulation is intact. Ninthly, test the splice using a multimeter to verify continuity and insulation resistance. This will help to identify any potential problems before energizing the cable. Tenthly, document the splice, including the location, date, and type of splice kit used. This information can be helpful for future maintenance or repairs. The NEC provides specific guidelines for splicing conductors, which may apply to SE cable depending on the situation. For example, NEC Section 310.14A3 discusses the need for approved methods for splicing conductors. NEC Section 110.14 covers electrical connections and splices, requiring that they be made with suitable connectors and that they provide a secure and reliable electrical connection. Furthermore, local electrical codes may impose additional restrictions or requirements on splicing SE cable. It is essential to consult with the local electrical inspector or authority having jurisdiction before performing any splicing work. They can provide guidance on the applicable codes and regulations and ensure that the work is done safely and correctly. In some jurisdictions, a permit may be required for splicing SE cable. This permit ensures that the work is inspected and complies with all applicable codes and regulations. If a permit is required, it is essential to obtain it before starting any work. Splicing SE cable can also affect the warranty of the electrical system. Some manufacturers may void the warranty if the cable is spliced using non-approved methods or materials. It is important to check the warranty terms and conditions before performing any splicing work. Consider the long-term reliability of the splice. Even if a splice is properly made, it is still a potential point of failure. Over time, the splice may loosen, corrode, or otherwise deteriorate, leading to electrical problems. Replacing the entire cable run may be a more reliable solution in the long run. The type of SE cable also affects the splicing requirements. There are different types of SE cable such as type SE, U, then type SE, R. Each type has its own specific construction and installation requirements. Ensure that the splice kit is compatible with the type of cable being used. Type SEU cable typically has a grey outer jacket and is used for underground service entrance applications. Type SER cable typically has a black outer jacket and is used for above-ground service entrance applications. When splicing SE cable, it is important to maintain the integrity of the neutral conductor. The neutral conductor is essential for providing a return path for the current and for ensuring proper operation of electrical equipment. Ensure that the neutral conductor is properly spliced and insulated. The size of the SE cable also affects the splicing requirements. Larger conductors require larger connectors and more robust splicing methods. Ensure that the splice kit is rated for the size of the SE cable being used. The voltage rating of the SE cable is also a factor to consider. SE cable is typically rated for 600 volts. Ensure that the splice kit is rated for the same voltage. Consider the environmental conditions in which the splice will be located. If the splice will be exposed to moisture, corrosion, or extreme temperatures, it is important to use a splice kit that is specifically designed for those conditions. There are splice kits available that are rated for direct burial, meaning they can be buried underground without additional protection. These kits are typically filled with a gel or epoxy that seals the splice and prevents moisture from entering. If the SE cable is damaged due to a fault, it is important to identify the cause of the fault and correct it before splicing the cable. Splicing a damaged cable without addressing the underlying fault will likely lead to a recurrence of the problem. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes splicing SE cable. Ensure that the splice is properly installed and that all components are securely fastened. Avoid creating a messy or unprofessional-looking splice. It is important to use the correct tools for splicing SE cable. Using the wrong tools can damage the cable or the connectors, leading to a faulty splice. Invest in high-quality tools that are specifically designed for splicing SE cable. Consider the accessibility of the splice. If the splice is located in a difficult-to-reach area, it may be more difficult to maintain or repair in the future. Choose a location for the splice that is easily accessible. Take photographs of the splice before and after it is completed. This documentation can be helpful for future reference or for insurance purposes. If you are not comfortable splicing SE cable yourself, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform the work safely and correctly. They will also be familiar with the local electrical codes and regulations. When hiring an electrician, be sure to check their credentials and references. Ensure that they are licensed and insured. Ask them for a written estimate before they begin any work. In conclusion, while splicing SE cable is possible, it's generally discouraged due to safety concerns. When unavoidable, adhere strictly to NEC guidelines, use approved splice kits, and prioritize safety above all else. Consulting with local electrical inspectors and hiring qualified electricians are crucial steps in ensuring a safe and compliant electrical installation. Replacing the entire cable run is often the safest and most reliable long-term solution.